transmission lines. So I'm going to discuss different types of transmission lines and transmission line parameters, transmission line equations, secondary constants of transmission lines, characteristics of wave propagation and different transmission lines loading. First of all, what is the transmission line? The main purpose of transmission line is to send information from one point to another line. The transmission line is defined as out of carrying information, the form of electromagnetic wave from source to load. Guided structures serve to guide the propagation of energy from source to load. So here there is one transmission line, figure A, that is required in transmission line from signal generator to here. So here, coaxial transmission line sending information from signal generator to CR. Figure B, there is one transmission line that is in between antenna and P. So here, transmission line send information from antenna to TV. So there are different types of transmission lines. One is parallel wire transmission line, coaxial line, waveguides, optical fiber, microstrip lines. Parallel wire transmission line. So it is a combination of two parallel conductors. So these conductors are separated by air as dielectric and mounted on posts or towers. So these parallel line transmission lines, there are two types. First one is low frequency high power lines, high frequency low power lines. Example for low frequency high power line, that is electrical power line. Example for high frequency low power lines, telephone lines. So these transmission lines are balanced with respect to earth and affected by atmospheric conditions like wind, air, ice, etc. And also possibility of shorting due to flying of objects and birds. So these transmission lines are suitable for frequencies up to 100 megahertz. So these are parallel wire transmission lines. Next, coming to coaxial transmission line. Coaxial transmission line, it is also a combination of two conductors. So in this type, one conductor is allowed to the second conductor being located inside and coaxial with the tube. Dielectric between two conductors may be solid or gas. To avoid radiation losses taken place in open wire lines at frequencies beyond 100 MHz, a closed field configuration is employed in coaxial cable by surrounding the inner conductor with an outer cylindrical hollow conductor. The main advantage of coaxial transmission line, there is no leakage of signal to the free space. Here, outer conductor providing electromagnetic shielding. So main difference between transmission line and antenna. So transmission lines must send energy only along it. Antenna must send energy into the free space. You can say antenna is one lossy transmission line. So these are coaxial transmission lines. So coming to waveguides. So waveguides, these are hollow metallic structures. A transmission line consisting of suitable shaped hollow conductor which may be filled with dielectric material and is used to guide ion wave of ultra high frequency propagated along its length is called waveguide. Waveguide allow to pass different signals simultaneously. However, different signals being propagated through a line must have different frequency, but in waveguide, they can have same frequency provided that each is propagated at different mode. This kind of multiplex transmission power handling capacity of waveguide is higher than coaxial cable. The main advantage of waveguides, the waveguides power handling capacity is more and signal loss is very low. So these are different waveguides. First one is here parallel plane waveguide, next rectangular waveguide, next circular waveguide or cylindrical waveguide. So these waveguides are fabricated based on skin depth concept. So what is skin depth? Skin depth is measure of depth to which electromagnetic wave can penetrate the medium. So skin depth in silver is small. The difference in performance between pure silver component and silver plated brass component is negligible. So silver plating is often used to reduce material cost of waveguide components. So in the waveguide, signal is propagated between two conducting walls with multiple reflections. So coming to optical fibers are working on the principle of total internal reflection. The main advantages of optical fiber, superior transmission quality, high information carrying capacity due to test bandwidth. Lightweight, smaller size, also cost of optical fiber somewhat low and information security is high. So these optical fibers mainly working on the principle of total internal reflection. To satisfy this condition, here core refractive index should be greater than planning refractive index. Coming to microstrip lines, so these lines are particularly important in integrated circuits where metallic strips connecting electronic elements are deposited on dielectric substrates. Microstrips are used for circuit components such as filters, couplers, resonators, and amplifiers. These lines having greater flexibility. Next topics we will discuss in the next. Thank you.